So for this video, I want to show some chemistry with acetylene, specifically in making 1,4-butyne-diol, which is industrially made with only formaldehyde and acetylene, using copper acetylide as the catalyst, which is then often hydrogenated to 1,4-butyne-diol, which is used to make THF and polymers, among other things of course. Anyhow, it just looks like a cool and unique reaction, and I just wanted to try it. So let's get started with making the catalyst first. So I set up a stir plate and a beaker, and I add in a stir bar. Then I add in 75 ml of water, and to that I add 10 grams of copper 1 chloride, but it's definitely not pure, evident from its disgusting color. I wash out the beaker with about 50 ml of 25% ammonia. That turns blue, and I add that to the mixture. The mixture also immediately turns blue, but this is actually from the ammonia complex with a copper 2+ impurity, because the 1+ complex is colorless. I add some more ammonia to make sure it all reacts, and in the meantime I set up an acetylene generator. It is just a flask with a dropping funnel, and into that I add some calcium carbide pieces, which basically look exactly like rocks. I add some water to the dropping funnel, and then to the flask I connect the gas adapter with a hose. On the right side of the flask I have connected a nitrogen cylinder. I first purge the air out of the apparatus by blowing nitrogen through it, and then added some of the water to the calcium carbide, which generates acetylene. The acetylene immediately reacts with the copper 1 complex to produce brick red copper 1 acetylide. I continue generating acetylene by adding water to the calcium carbide, and wait until no more copper acetylide is produced. In the reaction, the acetylene reacts with the copper 1 complex to form copper 1 acetylide and ammonium chloride. Or if we ignore the complex, we can write it as a direct reaction between copper 1 chloride and acetylene to produce copper acetylide and hydrogen chloride, which would then immediately react with the ammonia. After a while, no more precipitate forms when acetylene is bubbled through the mixture. So I take it away and set it up for vacuum filtration. I've added a filter paper on top and wet it with some water. I then filter all of the mixture through. I wash it with a bunch of water to remove all of the complex, salt and ammonia. I make sure to not pull it dry, since the copper acetylide becomes shock sensitive when dry. I take all the wet pasty residue and transfer it to a dish, and we are then left with some wet copper 1 acetylide, though the yield is unknown, because I can't measure it while it's wet, but it's probably pretty decent. All of the remaining bits of residue on the filter I destroyed with concentrated hydrochloric acid. Now that the catalyst has been prepared, I can set up the reaction. So I set up a large flask with a stir bar and put it in a water bath and start heating it to 60 C. I then add in all of the copper acetylide I just made. In between adding the catalyst paste, I start adding a total of 188 ml of a 37% formaldehyde solution. I then add a two-way gas adapter connected to a vacuum pump and a balloon filled with acetylene. I pull a vacuum to remove most of the air, then close it off and open the way to the acetylene balloon, causing the flask to be filled with an atmosphere of acetylene. I do that a few times to make sure most of the air is removed. I then keep the way to the acetylene balloon open to allow for constant consumption. When the balloon becomes empty, I replace it with a new one, and I occasionally redo the pumping process if the consumption seems to be very slow. In the reaction, the acetylene reacts with two equivalents of formaldehyde in the presence of copper acetylide to produce 1,4-butyne-diol. The first thing that likely happens is the coordination of acetylene to the copper from the catalyst. This causes the activation of the triple bond and weakening of the CH bond. The bond electrons from the CH bond in acetylene are able to attack a copper atom from another copper acetylide molecule, or potentially a free copper plus atom, causing those bond electrons to move onto the carbon, after which they take up the remaining proton, or it is simply released as H+. A cascade of reactions then takes place, where the copper-carbon bond electrons attack the carbonyl carbon of formaldehyde. One of the double bond electrons moves onto the oxygen, and then takes up an acidic proton from the copper acetylide that the copper was stolen from, or a free proton in solution. This then takes back the copper to regenerate the copper acetylide. We are then left with propargyl alcohol as the product. This then happens again on the other side to produce 1,4-butyne-diol. I left it running for about a week and the consumption was really slow, but it was definitely doing something. After this time, I became tired of it, so I decided to stop the reaction, even though it was still consuming acetylene. So I take away the water bath and let it cool down to room temperature. I then pump out all of the gas from the flask and let the air back in. I then take the mixture and set it up for vacuum filtration to remove all of the catalyst. I then wash the flask with concentrated hydrochloric acid to destroy the catalyst that is sticking to the flask, and also free product that might be trapped in there. The product can also chemically stick to the catalyst. So I just destroy the catalyst on the filter with concentrated hydrochloric acid and let that mix with the same filtrate, which will also destroy any catalyst that came through. Adding acid will simply convert it back into copper 1 chloride and acetylene. In literature, it is said that you can recycle the catalyst indefinitely if you wash it normally, but I don't want to keep it around. I then neutralize this filtered with sodium bicarbonate until it stops foaming. When that is done, and the mixture is slightly basic, a precipitate forms, likely from copper chloride, which is very insoluble in neutral and alkaline solutions. I then set this mixture up for short path vacuum distillation, to first remove all of the water, methanol, and formaldehyde. When it is mostly gone, we see a white solid in the condenser, which is probably from water steam distilling the product. What is left behind is just a black sludge, so I add some DCM to wash out the product. I did that several times, and it should have taken up the product. I set it aside for a second, and then add the distillate from before to a separatory funnel. Since we saw it was steam distilling some of the product, and also it kind of smells like the product, I will extract it with DCM, to hopefully recover some of it. I then combine the extracts, and dry it with some anhydrous sodium sulfate, to take up remaining water. I filter it through some cotton, directly into a flask, and set the filter up for short path vacuum distillation, to first remove all of the DCM. When all of the DCM is gone, a yellow liquid is left behind, which should contain the product. So I increase the temperature and pull a strong vacuum to distill it all over. At first, a clear liquid comes over, but afterward, a solid starts forming in the condenser. The product should be a solid, but it seems most of this was just a liquid. So when the distillation was finished, I was left with a clear liquid, in which the solid slowly dissolved again. I then tried to redistill this liquid under a milder vacuum. At first, a clear liquid starts distilling over like before, at a temperature of around 140 C at around 50 millibars of pressure. In literature, it is said that propargyl alcohol is one of the side products, but if the liquid is propargyl alcohol, it is 1. Way too much, and 2. The boiling point doesn't match, and actually matches 1,4-butyne-diol a lot closer. So maybe it's just impure and coming over with a lot of crap. Maybe the impurities make it liquid. I don't know. Anyhow, after a while it kinda stops, and I swap the receiving flask, and I have to increase the temperature to get the next bit to come over, which happens at about 160 C. That solidifies in the condenser again, and I liquefy it with a heat gun. After that, I am left with 19.31 grams of a clear liquid as the first fraction, and 1.27 grams of a white solid as the second fraction, which should be mostly 1,4-butyne-diol, though I don't really know if the liquid is also mostly butyne-diol, mixed with some impurities, since propargyl alcohol has a boiling point that is 100 degrees lower. So that should have come over earlier, but it didn't, even if it is present. So the best option might be to hydrogenate this crude product, and then try to separate it afterward. But I also tried to do a fractional distillation at regular pressure, and that didn't really work out, and the liquid turned black. So I guess that won't go through. So I quit, cause this stuff is kinda annoying. See ya.